Hello dear EAPCET aspirants, this is our day 4 of EAPCET 2026 series. I hope you have seen all the previous sessions that we have conducting from last 4 days. So every day we will be having all the subjects like physics, chemistry, bio part for BPC students, and for MPC student mathematics will be starts very soon. Okay, so you just follow our channel for daily classes and you can use this at most priority basis for your preparation. Okay, so ee roju mana topic classification of elements and periodicity in properties. So first of all I will show you few questions related to this topic in the exam. Okay, so look at here, we have some PYQs first. See, before discussing the concepts, నేను మీకు కాన్సెప్ట్ చెప్పే ముందు మీకు కొన్ని PYQs చూపిస్తాను, so that we'll get some clarity what kind of questions are there in the exam, are appearing in the exam. So look at this first question and see. So these questions are based on simple electronic configuration. So every student who are watching this video or whatever the exam you might be preparing for JEE, NEET or EAPCET or even for boards like IPE exams also, you need to know the basic electronic configuration. If you know the basic electronic configuration, you can answer these questions. First 3 questions are simple based on electronic configuration, okay, and the next questions are based on periodic table. Who proposed periodic table? What are the developments we have, like Dobernier triad, Lothar-Meyer, next what we have, Newland's law of octaves, Mendeleev classification, right now. So most less periodic table, based on that we have one question. And see, next we have basic IUPAC nomenclature for elements having atomic number greater than 100. Okay, this is on that. And look at this question, this is based on nature of oxides, whether they are acidic oxide, basic oxides, like that. So every concept will be discussed here. Complete chapter we will do in this one session. Okay, so if we have time, all these PYQs will be solved here itself. So just stay connected with this channel and you can share with your friends. Okay, look at here. Next we have based on periodic properties, like what are the periodic properties we'll study in this chapter in periodic table, like how electronegativity varies in the period or in the group, and electron gain enthalpy variation in period and group, and ionization energy variation, atomic radius, ionic size, all these things will be discussed. Metallic nature, see, based on that we have one question. See, there will be at least one question based on periodic properties in exam from this topic, from this chapter. Okay, so you should definitely solve question from like questions which are related to periodic properties. Okay, practice the concept, learn the concept, practice the questions related to periodic properties. Just follow, I will show you. Okay, so again oxides, carbonates, stabilities, all things are given here. Metallic nature, see, very simple, this chapter is very simple. Just we need to learn the theoretical concept and we need to apply them in the questions, that's it. And this is a very basic topic, you must know to understand the other chemistry subjects, other chemistry parts. Okay, so for example, if you wanted to understand chemical bonding, you need to know the idea of electronic configuration, how they are filled right now. So this is very basic topic, that's why. Okay, so first of all we have classification of elements. Classification of elements were done because of to understand that the elements which are having similar properties to be kept at a site, I mean at a place. All together the properties of all the elements which are present in one single block or one single period or in one single group, I can say, in a group, that can be understood by looking at their one property. I mean, for example, if I take carbon family, so what is the general electronic configuration here we are writing? So we will writing it as Ns to Np2 right now. So it means all the elements which are lies in that 14th group element in the carbon family, we are saying they have similar chemical properties and similar electronic configuration. If they have similar electronic configuration, their reactions also looks to be similar, that's why. Okay, so now for this classification, the first person here is Dobernier triad. So what he given, what is his approach? He classified the elements based on atomic weights. So what he did, so he taken elements in the increasing order. So every set of 3 elements he taken triad. Triad means what? Set of 3 elements. So the atomic weight of middle element is the average of the first and third element. Okay, so this is what he considered. For example, here look at this. He taken the triad of lithium, sodium, potassium. Now the atomic weight of sodium considered as average of atomic weight of lithium, potassium. It means atomic weight of first and third element average will be equals to the middle element, that is sodium here. Okay, so this is how the classification were done. Okay, but this Robernier triad were applicable for only few set of elements. Okay, so if it is not applicable for all the elements, he was unable to answer why it is not applicable to all the elements, and some elements were taken in such a way that they are having very large difference, and some elements were having very small difference in their elements. For example, lithium to sodium, here if we observe, we have one type of difference, and if we take some elements like in the period, they will be having difference in their differences. So there was no proper explanation for this kind of scenarios, and this law of triad, like this triads, whatever he's taken, that new law like Robernier triad, this is applicable for only few elements, like lighter elements only, not applicable for all the known elements. Okay, therefore this law got failed. Okay, so now this is one thing, and the next, Newland's law of octave. So what he considered? So he considered elements in the increasing order of their atomic weights. For every first element and 8th element are having similarities in their properties. Okay, so that is what, like sa re ga ma pa da ni sa again. So it means like 8th musical note we are saying now, like sa re ga ma pa da ni sa again. Okay, something like that. See, lithium again sodium. See, 1, 2, 3, 4, 5, 6, 7, 8. Again 8th element is having similarities with the first element. So that's why lithium and sodium, we know they have, like both of them are alkali metals, they will show similar chemical properties. When upon reacting with any substance, they will releases one electron and forms respective oxides we are discussing now. Why? Because they belong to same group, that is what we understood later. Okay, right. So now this rule is valid up to calcium and fails to applicable in the case of heavier elements. So this is also applicable only to to some extent only, not to the all the elements known at that time. Therefore this law got also failed. Okay, then next. So now when this law proposed, there were no noble elements, noble gases were not discovered. That's why we got every first element to 8 elements similarities in their property. So once after discovery of these noble gases, they were inserted in between these. Now as we consider present, the similarities will be every first element will be with the 9th element. Okay, because now at present we have noble gases also in between. That's why. Okay, hope this is also clear. Right. Next, Luther-Meyer curve. So Luther-Meyer given his classification by taking a curve like atomic volume versus atomic mass. So when atomic volume versus atomic mass curves are drawn, he have seen some elements are occupying some specific positions. For example, like all the alkali metals were seems to be absorbed like present at the top of that peak. For example, here you can see like sodium is at the top of this peak, and potassium is at the top of this curve, and rubidium here you can see. So it means what he told, those elements which are having similarities in their properties occupies similar positions in these curves. Okay, so now what are those positions? See, look at here, I have generalized them. See, alkali metals such as sodium, potassium, rubidium, which have similar properties, occurs at the peaks of the curve. Okay, these points, these 4 points are very important here. Okay, so they can directly ask in this Luther-Meyer classification or Luther-Meyer curve, what are the positions of this particular element? It means, for example, alkali metals will at the top of this peak, and the next halogen elements like halogen atoms are at like fluorine, chlorine, bromine, which have similar properties, occurs at the rising or the ascending part of the curve. This term ascending part of the curve, it means, look at this curve, see ascending part means what, see rising or ascending means, see this is what the ascending or rising now. So like this, see here fluorine we have, again chlorine we have, okay, just before the noble gases there, okay, and here you can see bromine. So this is what increasing curve or ascending curve we can say, right, smaller to big we are saying now, right. So similar to that, just after the noble after the halogens we have noble gases such as like neon, argon, krypton, which have similar properties are just before alkali metals and just after the halogens. You can remember these statements. Next, hydrogen and helium seems to be exception to this rule because they are occupying some other position. See, all helium gases were occupying similar positions except helium. So that's why it is considered to be exception in that curve. Okay, next, Mendeleev classification is based on what? Atomic weight, right now. So atomic weight here. So again, when Mendeleev given his classification, there are 63 elements known, okay, it is based on atomic weight, okay, and he is the first person to classify like groups and periods. So what he told, horizontal rows are considered as periods and vertical columns are considered as groups, okay. Now look at here, see each group, see actually there were 8 groups in the Mendeleev's classification. Each group, that is up to 7th group, I mean first to 7th group are subdivided as 1A and 1B, like that, 1A, 1B, like that, up to 7th it is classified, 1A, 1B, 2A, 2B, 3A, 3B, like that, up to 7 groups it is classified, okay. Now 8th group, that specifically that 8th group consists of 9 elements which are considered as transition, which are like transition metal groups. I will show you in the periodic table, just hold for some time. Okay, so now what are the merits, what is the advantages of his classification, Mendeleev's classification? See, Mendeleev consider there are some, he predicted there are some elements which might be discovered in future, so let's leave some space for them. So by considering this, so he just left some space for unknown elements by predicting some elements might exist in this particular space in a group or in a period. So like that he have provided space for gallium by mentioning it as Eka aluminum. In the examination they will give what is the Eka aluminum or what is the name of gallium out of the following, okay, and Eka boron for scandium, Eka silicon for germanium, Eka manganese for technetium, okay, you can remember Eka aluminum gallium, aluminium gallium, okay. Next, boron scandium, silicon germanium, manganese Eka manganese technetium, like this you can remember, okay. So what are the demerits? See, he classified based on atomic weight, but we know there are something called isotopes right now. So isotopes means they have different mass numbers. For example, carbon if I take, it will have C12 and C13. So it means these are having two different atomic weights, means special special or separate space or position should be given for these 2 elements, but he considered all carbon elements at one position, means he was not neglected isotopes, but isotopes should be given different space now in the periodic table because they are having different atomic weight, but he was not given those kind of positions, okay, like position of isotopes. I hope it is clear. This is one demerit, okay. Next one is position of hydrogen. See, hydrogen resembles with both alkali metals and alkali metals and halogens. Alkali metals means what? First group element like sodium, lithium, all of these are having NS1 configuration. Our hydrogen is also having 1s1 configuration. So similar electronic configuration, and if I give one more electron to hydrogen, it becomes 1s2 helium gas configuration, noble gas configuration it is getting right now. So similar to, this is similar to what? It is similar to halogens. Like halogens, fluorine if you take, it has N, like halogens have NS2 NP5 configuration. By giving one more electron, they will get like respect to inert gas configuration. For fluorine, neon gas configuration, like that. So similar scenario will be seen here in hydrogen case. It means hydrogen is having properties similar to, or properties are similar to what? Both noble gases as well, both for halogens as well as alkali metals. So the position of halogen was not justified exactly. So till now the position of hydrogen is not satisfied. Okay, right. Next, anomalous pairs. There are some elements which are having higher atomic weights were kept before the lower atomic weights. So those elements, those pairs are considered as anomalous pairs. It means what? For example, there is element B and element A. So element A is having higher atomic weight than B, but it is placed before. Because we know in this periodic table is arranged based on increasing atomic weight, but element A is having higher atomic weight, but it is kept before this lower atomic weight containing B element. So these are considered as what? Anomalous pairs. So for example here, see argon having 39.9, whereas potassium is having 39.1. So as per his classification, potassium should come first, next argon. But what is the scenario here? Argon is coming first, next potassium. So these now argon and potassium is considered as anomalous pair. Similarly, cobalt and nickel, they are also having different atomic weights. Check, right. So next we have Henry's classification. So he given his periodic table based on increasing atomic number. So what is that? Increasing atomic number. So atomic number comes from where? It comes from number of protons present in that particular element, right now. So if atomic number increases, like number of protons increases, atomic number also increases. So based on this approach, we have Henry's classification. So in his periodic table, there are 18 vertical columns called groups. So first 1 to 8 group and 0 group, which is inert group they are saying, okay, inert gas. Okay, so inert gases were introduced in the periodic table by Ramsay. Who is that person? Ramsay. Okay, these are the names, you need to know those names also, whoever contributed here. So there are 7 horizontal rows called periods, right? Okay, so now what are the merits here? So first merit is position of isotopes. So in the Mendeleev periodic table we have seen that position of isotopes were not justified. It is a demerit there. Here it is overcome, like in his classification that drawback were overcome here. See, the position of isotopes were satisfied. How it is satisfied? Because now it is not depending upon their atomic weight, it is purely on their atomic number. So all the isotopes having same number of protons, no? If same number of protons, same will be the atomic number, right? Yeah, next. Now there is nothing like anomalous pair, because anomalous pair is given based on their atomic weights. Here we are not talking with respect to atomic weights, here purely based on atomic number. So whichever having more number of protons, that will comes next, having less protons comes first. Okay, so like there is no anomalous pairs here. Next, here lanthanides, actinides are in third B group. In which group? Third B group, you can remember. Okay, next, just give me some time. Okay, next. So what are the demerits here we have? See, demerits, position of hydrogen is still controversial. Why it is? Having similarities in properties, na? So whether to place in first position or in the alkali metal family or in the halogens were not yet confirmed. That's what it is controversial, he is mentioned. Okay, so helium is inert gas, but has different electronic configuration than the other inert gas elements. Like other inert gas elements are having like NS2, NP6 configuration, but helium is having NS2 configuration. So that is what here it is mentioned. Okay, next. Yeah, so this is the periodic table. Okay, so if you see Mendeleev classification, what he told, it is considered as 1A, 2A. So this is S block. This is what block? S block, and this is P block from 13 to 18. Okay, and this in between we have D block, and this bottom one is called F block. Okay, remember here this S block and P block are considered as main group elements. What is that? Main group elements. So in these main group elements, we can write their numbering as 1A, 2A, and this is 3A, 4A, 5A, 6A, 7A, like that. Okay, and when it comes to D block, our copper family is there now, having electronic configuration as 3D10, 4 is 1. So it is considered as 1B, this is 2B, and next scandium group is considered as 3B, so on like that. Okay, so this is what we have seen as per the Mendeleev classification and all. After that, IUPAC given numbering as starting from S block continuously given up to this last noble gases, like 1, 2, 3, 4, 5, 6 like that up to 18. So how many groups are there now? 18 groups are there. What are the groups present in S block? First group and second group. What are the groups present in P block? From 13th group to 18th group. What are the groups present in D block? That is from 3rd group to 12th group. And here lanthanides, actinides, that F block elements are present in this 3rd group only. So here it is mentioned as lanthanum now. So in this lanthanum, at the same position only, we have all these 14 lanthanides, and at the position of this actinide only, we have all these 14 actinides. You can remember this. Okay. Now elements which are lying in same group will be having same electronic configuration. Like boron family, it will be NS2 NP1 electronic configuration, and for carbon family it is NS2 NP2 configuration, like this. Okay, okay, right. Next, look at here. So now we are going to study periodic properties. What are these periodic properties means? See how size of an element varies. If I go from top to bottom, how the size of an element varies, that is given in terms of radius now. How atomic radius vary from top to bottom, or how atomic radius varies from left to right in the periodic table, or I can say this is horizontal rows which are called as periods now. How atomic radius varies in a period, how metallic character varies in a period or in a group, how electronegativity varies in a period or a group. Like this we need to study now. Okay, so look at this. Before going to the periodic properties, see in the periodic table if you observe, there are 118 elements were known. Okay, so now elements having atomic number greater than 100, we have some certain rules to give their naming. Okay, so those are given by IUPAC. So what he is saying is, so for example there is an atomic number 122. So how can we write the name of this element? See, when we have 1, you should call it as un. Okay, so when we have 1, you should call it as un. When we have 2, you should call it as bi. Okay, again here also 2, bi, un by, like 22 na, IUM, you can add word IUM. Okay, and if you want to give the symbol for this, you can put U capital letter, B, B. This will be the symbol of this element with atomic number 122. Okay, for example we have atomic number 118. Tell me how can I write? 118 means 1 means un. Okay, again 1 un 18. 8 means what? Oct. Oct, IUM, octium. So the symbol of that element will be UUO. UUO. So I hope you got this. Now tell me what is a symbol or what is the name of an element having atomic number like 143. So tell me what is the element, if there is an element in future having atomic number 143. So what is its symbol? Tell me in the comment box. Okay, hope you will answer this. Next, let me go forward. See, in the exam they will be saying like element with atomic number 101 can be written as anil-anium. No? So what is a anil-anium element, or match the anil-anium element with its name now. What is the present name here? It is Mendeleevium. Okay, what is its official name? I can say Mendeleevium. So unnil anium is called Mendelevium. Again similar to 1 or 2 means nobelium. What is its nobelium's IUPAC name? Okay, 1 or 2 means what? 1 means un, 0 means nil, unnil bium. UNB is a symbol right now. So that's how they will ask in the exam. Okay, let's move forward. Okay, so how can we predict? There is a question in EAPCET based on this. How can we predict group and period of a particular element? Okay, so block, it means whether it is S block, P block, like that. So the last electron enters into which orbital? So by looking at the electronic configuration, if that last electron entering into S orbital, we can say S block. If it is entering into P orbital means P block. Similarly D means D block, like that. Okay, so next period. How can we calculate period or predict the period? Maximum value of principal quantum number. For example, I am writing for element like magnesium. What we can write? Its atomic number is 12. So 1s2, 2s2, 2p6, 10 over, 3s2, 12 over. So what is its group or block? I can say, so last electron entered into S block now, so it can be S block element. Okay, and next, what is its period? If I ask, what is the highest principal quantum number? This coefficient number we are seeing 3, so it belongs to third period. Okay, and next group S block. How can we find? For S block, if it is number of valency electrons, so how many valency electrons are there here in S block? Means here 2 valency electrons, so it belongs to second group. Okay, and then next for P block, number of valency electrons plus 10. Okay, so this is second period, directly second group we can directly say here, because number of valence electrons in S orbital you just check. When it comes to P block element, if that last electron entering into P block, you can take 10 plus that number of valence electrons in that P orbital. For example, carbon I am writing, you can say 1s2, 2s2, 2p, 2 configuration right now, atomic number 6 means. Okay, so here I can say 10 plus number of p orbital electrons. How many p orbital electrons are there? P and S valence electrons are the number of p and like valence electrons I can say. Valence. So how many are there valence electrons? 2 plus 2, 4 you can take. So it belongs to 14th group 14th group of this periodic table. So P block means number of valence electrons plus 10. So why we need to add 10? Because between S and P we have one more set of elements. What is that? D block elements, na? Those are 10 elements are there in a series. That's why we are taking 10 plus 10 here. Okay, and when it comes to D block, just take it as number of NS electrons. After S electrons only we have D block now. So plus number of D electrons, that is n minus 1 D electrons. That gives you which group it is in the D block. Okay, for example, I am giving you iron. See, there is a question on this. Iron I am giving you. Its atomic number is 26 and its electronic configuration, valence electronic configuration is 3d6 4s2. Now what is its group number? Just add these two numbers. So it will be 8th group element. That's it. For F block, it is fixed as third B only. Okay, there is no change. Okay, right. All the F block elements, lanthanide, octanide present in third B group right now. Therefore, its group number is fixed. Next, properties. Atomic radius. First property is what? Atomic radius. So atomic radius, what happens down the group? Atomic radius down the group increases. Why it is increases? See, we have, let us take first group elements, lithium, sodium, potassium, rubidium, cesium, you take it like this. See, smaller size. Why it is smaller size for lithium? Because write its electronic configuration, atomic number 3, so 1 is 2, 2 is 1 we are writing, and for this it will become 3s 1, and for this it will become 4s 1. Here noble gas will be there, and here 5s 1, and here 6s 1. So if you observe this number 2, 3, 4, 5, 6, that principal quantum number is getting increased. If principal quantum number increases, for example, if this is a nucleus, see this is first principal quantum number, second principal quantum number, third principal quantum number, like this. As n value increases, the size, the radius of that particular atom also getting increased. So down the group, what happens to the size? Size increases. So you can remember, down the group, size of that elements increases. Okay. So next, when we are going from left to right in a period, now what happens? Take the elements like lithium, next beryllium, boron, carbon, nitrogen, oxygen, like this if we take. Now what happens is, if you observe their electronic configuration, it will be like 1s2, 2s1, this is 2s2, this is 2s2, 2p1, 2s2, 2p2. It means their principal quantum number, if you observe, the principal quantum number is being fixed now. What is its principal quantum number? 2 only. Number of electrons are increasing, but that increased electron is going to where? Into the same nth level now. Principal quantum number is fixed. It means they are going into same principal quantum number, like this only. If they are going into these, see, we know atomic number also increasing. Here it is 3, 4, 5, 6, 7, 8. So atomic number got increased. If atomic number is increasing, it means number of protons are increasing, but the electrons which are coming inside are into the same orbital, same energy level, therefore they attracted towards the nucleus more effectively, because number of protons in the nucleus are getting increased as atomic number increases. Therefore what happens to the size? Decreases. So across the period from left to right, their size decreases. You can remember this. Okay, what happens to the size? Size decreases from left to right. Okay, remember this. So now what we can give the order, like how we can give lithium is greater than beryllium, greater than boron, greater than carbon, greater than nitrogen. Okay, so based on this, just hold for some time. We will cover few more topics like complete periodic properties we will finish, then we will solve the questions. Okay, just hold for some time. Now look at this graphical representation also. See, lithium, beryllium, boron, carbon, oxygen. Now these are period elements only, second period elements. Now what happening from lithium to fluorine, from S block to P block, what happening? From S to P. So the size is getting decreased. See, this is the data, this is the graph, and this is the data we have. See, lithium, beryllium, carbon, if you go like this, their size is getting decreased, which is having maximum size. Always S block elements will be having maximum, then P block. I mean, from comparing S and P block as per the data. Okay, so look at their values also if you want. Similarly, third period elements you can check, sodium, magnesium. If you consider all this, see, size is getting decreased as we move from S to P block, right. Next, look at this variation in group. So how these values are varying in the group, I told you. So due to increase in the principal quantum number, size increases when we go from top to bottom in a group. Okay, so look at these elements: lithium, sodium, potassium, rubidium, cesium. See, as we grow from top to bottom, their size, their values getting increased. So atomic radius increases down the group. Okay, see, look at their data, practical evident graphs we have here. Okay, now ionic size. Ionic size means what? Atom means it should be in the neutral form. So ionic form means I may take its anion, like by adding one electron to this atom A, it becomes anion A minus, and removing one electron it becomes A plus. So I can say A plus is cation, A minus is anion, and A is a neutral atom. Okay, so now whenever we are considering atomic ionic radius of these three species, what happens? If the radius of these three species will be, always remember, for a particular element, more is a negative charge on it, greater is the size, because more is a negative charge means more number of electrons it has. If it is having more number of electrons, its electron cloud will be expanded around the nucleus. If it is expanded means size will increases. So anion will be always greater, then next atom, and next cation with a small charge. Okay, if more positive charge is there, smaller will be the size of that ion. Okay, remember that. Next, isoelectronic species. It means what? Iso means same, electrons. If the given species are having same number of electrons, we can say them as isoelectron. For example, you can see O2 minus, F minus, Na plus, Mg plus 2. See, atomic number of oxygen is 8, but minus 2 is there. It means 2 more electrons were added, it is becoming 10 electrons now. Okay, fluorine atomic number 9 minus 1, so it is also becoming 10 electrons. Sodium atomic number is 11, removed 1 electron, so it is becoming 10 electrons. So like this, we have all the species with 10 electrons only. But what is the change or variation in their size if they ask? Always remember, I told you, anions having more negative charge will be having larger size. So O minus 2, then next F minus, okay. After this, neutral atom, there is no neutral atom, take cation. Cation with a more positive charge will be smaller size. Why more positive charge, smaller size? Because more positive charge means less electrons, and more positive charge means that positive charge will attract or drag the electron cloud more effectively. Now, if it is dragging more effectively, size decreases. That's why. Okay, right. Right. So this will be the order. So what you can say, their radius or their size inversely proportional to nuclear charge. More nuclear charge, that means more positive charge, lower the radius. You can understand by this particular relation. Okay, right. Answer me for this NEET question. Anyways, I told you I am going to show you EAPCET questions, but as of now you answer this question. Correct decreasing order of atomic radii from lithium, beryllium, boron and carbon. Which is the correct order, you tell me. So just now I told you lithium is having greater size, S block elements first, next beryllium, next boron, least is carbon. That's it. This will be the order: lithium, beryllium, boron, carbon. Right? Next. Tell me here, there are 3 anions given, N minus 3, O minus 2, F minus. Give their order as per the mentioned. See, we know more negative charge, more is the size I told you. See, all of them are having 10 electrons only. It means isoelectronic species. So in isoelectronic species, more negative charge, more is the electron cloud, so greater the size. So O3 minus, N3 minus, O minus 2, F minus. So as per this, match the values having greater value for N minus 3, like 1.71 and then next 1.40 and then next 1.36, that's it. So third option will be perfectly correct for this, right? Next, ionization energy. What do we mean by ionization energy? For example, I have an element A, from this element A. So first of all, we need to convert this element A to its element A in gaseous state. Whatever might be the state, first of all we need to convert it into gaseous state. So from this gaseous neutral atomic state, we need to remove one electron. Okay, it becomes A plus. Okay, now the amount of energy required to remove an electron from this neutral gaseous element is considered as its ionization energy. Hope this is clear. The minimum amount of energy required to remove an electron from outermost orbital of isolated atom in its gaseous state is called its ionization energy. If I remove first electron, first ionization energy. If I remove second electron, second IE. If I remove third electron, third ionization energy, like this. Okay, always remember, removal of first electron is easier than the other electrons. Okay, so always remember, successive ionization energy if they ask, IE1 will be smaller, then IE2, IE3, so like this. So removal of first electron only very difficult. Okay, so as number of ionizations increases, their ionization value also increases. So IE3 is greater than IE2, greater than IE1, you can remember. Okay, right. Next, how this ionization energy varies in periods and groups. So when it comes to groups, what happens? The size becoming larger now in groups. So if atomic size is increasing larger, becoming larger, we can easily remove outermost electron because it is away from the nucleus. So down the group ionization energy decreases. Remember this. Down the group, what happens to the ionization energy? Decreases. Now when it comes to period elements, so when we go from S block to P block, left to right, the size of that elements decreasing in a period. So if size decreases, that electron is strongly held by the nucleus, therefore energy required to remove that electron will be maximum, more energy is required. Therefore left to right, what happens to their ionization energy? Increases. So left to right, from S block to P block, ionization energy increases, from top to bottom ionization energy decreases. You can remember them as a standard ways. Okay. Now there are some factors to be remembered here. First of all, let us conclude with some examples first. See, I am giving you in a period, in a group, like sodium, potassium, rubidium, cesium is given. Tell me which is having lower ionization energy, like order if I ask, sodium will be maximum, potassium, rubidium and cesium. Why? Because from top to bottom their size increases, therefore electron removal from cesium, that is larger element, can be easier. Therefore it is having minimum energy, minimum ionization energy. Okay, hope this is clear up to here. Now when it comes to period, so in periods ionization energy not only depends on size, it also depends on electronic configuration. What is that? Electronic configuration. Now look at the elements of second period like we have boron, beryllium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, neon. Always remember, if the electronic configuration is highly stable for that element, its ionization energy will be maximum. See, neon is having very stable electronic configuration, therefore its ionization energy will be maximum. After that, fluorine is more electronegative element, it required one more electron to gain noble gas configuration, so it is also having maximum. Okay. Now when it comes to oxygen and nitrogen, so now look at the electronic configuration for oxygen, you are writing 2s2, 2p4. When it comes to nitrogen, 2s2, 2p3. So 2p3 is a stable electronic configuration, a half filled electronic configuration. So removal of electron from nitrogen is very difficult when we compare with the oxygen. Therefore nitrogen ionization energy is greater than oxygen. Hope this is clear. And when between carbon and nitrogen only, because nitrogen half filled stable electronic configuration with high electronegativity than carbon. Now between boron and carbon. Now between beryllium and boron, see beryllium having 2s2 electronic configuration, boron having 2p1 electronic configuration, 2s2 2p1. So removal of this 2s2 2p1, removal of this 2p electron is easier than removing electron from 2s. Why? Because 2s orbital, s orbital shape is spherical, that is very close to the nucleus. So the penetrating capacity of s orbital is more, therefore removal of electron from s orbital is very difficult when we compare with this p orbital electron. Therefore beryllium ionization energy is greater than boron. Okay, hope this is clear. Between lithium and beryllium only. Okay, because always remember, alkali metals having lowest ionization energy. So due to their lowest ionization energy, they were used in the photoelectric cells. I mean photoelectric effect you will study now, like cesium, rubidium are used in the photoelectric cells. Because of lower ionization energy, they can easily emit the electron by passing light amount of energy. Okay, right, its electronic configuration is 2s1. So this one electron can be easily removed from lithium, that's why alkali metals. Okay, so what is the finalized order? Always neon, I mean noble gases, after that fluorine, after that nitrogen, then next oxygen, then next carbon, next beryllium, boron, least is lithium. You can remember this order. Okay, so now based on this, just solve this question. The successive ionization energy. Okay, this is one of the very good application. There are many questions in JEE and EAPCET NEET exam related to this. See, this is EAPCET question only. Look at this. The successive ionization energy is starting from the first of an element or 108 or 801, this is IE1, this is IE2, second ionization energy, and this is third ionization energy, fourth, like this they given up to fifth. Okay, which element it is they are asking. Remember what I told you, if we are able to remove electron easily, it will be having low ionization energy, If the removal of electron is very difficult, so it will be required high ionization energy, or more energy is required, so we can say high ionization energy. So look at the given examples, values. First three ionization energy values are almost nearer values right now, but this fourth ionization energy value is very large. It means the removal of that fourth electron is becoming very difficult. Therefore, first three electrons are what? Valence electrons, and the fourth electron is inner core electron. Removal of valence electrons are relatively easier when we compare with this inner core electron. So how many valence electrons are there in that given element? 3. So the element with the 3 valence electrons, here we need to calculate, or we need to look. Write their electronic configuration. Boron will be having atomic number 5. So 1s2, 2s2, 2p1. So how many valence electrons we are seeing here? 3. Okay. When it comes to carbon, you have 2s2, 2p4. 4 electrons are there. But what we know, 3 valence electrons are only there because looking at their ionization energy values. The fourth electron is very difficult. See, these 3 can be easily removed, but this fourth electron cannot be removed from 1s1, 1s2 electronic configuration. So which element is it? It is boron. Hope this is clear how we are solving this kind of questions, right? Right. Next, identify the species which are isoelectronic, again from EAPCET only. Tell me fast. 10, see, oxide, like oxide ion means what? 10 electrons here. Fluoride ion means also 10 electrons. Sodium also 10 electrons. Magnesium plus 2, 12 minus 2, 10 electrons. So all of them are what? Isoelectronic species only. So 1, 2, 3, 4, fourth option, right? Yeah. So now look at this. Ionization energy values, we need to match them. Which electronic configuration is most stable? We know nitrogen. Okay, this is nitrogen electronic configuration, and this is oxygen electronic configuration, and after that this is 4 electrons means beryllium electronic configuration, and this is 4 plus 5 boron electronic configuration. So tell me what is the order I told you? Nitrogen maximum, after that oxygen, after that beryllium, and least is boron. That's it. Okay, so it means boron is least, so this is the least value, and beryllium next, oxygen here, nitrogen here. That's it. Based on this you can answer the question from the given options. That's it, right? Let's move forward. Metallic nature. So remember, metallic nature from S block to P block or left to right, what happens to the metallic metallic nature, they will ask. See, S block elements are metals like alkali metals, alkaline earth metals we are seeing, whereas P block elements are non-metals. So from moving from S block to P block, metallic nature decreases. If metallic nature is decreasing, we can say these are non-metals. Non-metals are electronegative, metals are electropositive. So we can say from left to right, electropositive nature decreases and electronegative nature increases. You can remember this. And from top to bottom if we go, so as we go from top to bottom, they becomes heavier. So heavier elements are having more metallic nature. So down the group, metallic character increases for the elements. From left to right, metallic character decreases, and top to bottom metallic character increases. You can remember these 2 lines. So based on this, so metals exist in, metals are tends to exist in positive oxidation state, like positive electropositive nature they have. So due to this reason, metals can show greater reducing character. They can act as a good reducing agents. What I am saying, metals act as good reducing agent. What do we mean by reducing agents or reducing nature? They have tendency to release the electrons easily. If they are releasing the electrons easily, that electron is taken by someone. So that what happens, so that someone who taken the electron, they got reduced, their charge will becomes negative or lower number, okay, and these metals become positive oxidation states. For example, I am writing M here, M is a metal and X is a non-metal. Now metal will lose the electron and becomes M plus, okay, and that last electron is taken by this X element and becomes X minus. So now what is the difference you are seeing here? From change you are seeing M becoming M plus. This process is called oxidation. So metals are easily undergo oxidation by releasing electrons. So I can say the species which is undergoing oxidation are considered as reducing agents here. So metals are good reducing agents, and non-metals, which I have indicated with X, non-metals have tendency to gain that electrons, or I can say non-metals are electronegative now, so they have tendency to take the electron, drag the electrons. So they have tendency to gain the electron which comes from this metal, so they become X minus. So X converting into X minus. So what is this process? So charge 0 is becoming minus 1, number is reduced now. So this process is called reduction, and these non-metals have ability to oxidize others. See, X is oxidizing M now, so I can say non-metals are good oxidizing agents, whereas metals are good reducing agents. You can remember this statement, okay. So this is the order of the reducing character in gaseous state. In which state? Gaseous state, you can remember, okay. So when it comes to aqueous state, order will be same, but this lithium comes first only in aqueous state I am saying, okay. When it comes to oxidizing character, I have mentioned here, you can see. Next, electronegativity. So what is this electronegativity, or electronegativity I will discuss. Electron gain enthalpy. So what is this? See, for example, an element X is there, to that it is somewhat opposite to the ionization energy, you can understand in that way, okay. So if there is an element X, that must be in gaseous state, and it should be in the atomic state, not in molecular form, X atomic state. So the amount of energy released, mostly it will be released, okay, sometimes it is positive also, okay. The enthalpy change accompanied when an electron is added to neutral gaseous isolated atom, so that it becomes anionic form, okay. So during this process, energy might be released or absorbed. So whatever the enthalpy or energy change associated is considered as electron gain enthalpy, okay. So now see, when an electron is added to a neutral gaseous isolated atom to convert into a negative form, the enthalpy change accompanying the process is defined as electron gain enthalpy. Electron gain enthalpy provides a measure of ease with which an atom adds electron to form its anion. See, electron gain enthalpy, by looking at the electron gain enthalpy values, we can able to understand which element is having more tendency to take that electron, okay, to become its anion, okay. Yes, good afternoon in the comment box here. Who is that? Karthik. Yeah, okay. So what are the factors here? So size, effective nuclear charge, screening effect, electronic configuration are the factors affecting on the electron gain enthalpy. See, electron gain enthalpy is inversely proportional to atomic size. So smaller size if it is having, if it is a smaller size, it has more tendency to gain the electron. Why? Because smaller size means nuclear charges will be more now, that proton will be having more effective nuclear charge that can easily drag the electron. So small size, high effective nuclear charge having more tendency to gain the electron. So they have more electron gain enthalpy value, we can say, okay. And in electron gain enthalpy I am saying now, so electron gain enthalpy generally I will define it, amount of energy released here, okay, it will be given in negative terms. So more negative the value, greater the tendency to gain the electron, okay, you can remember in this way, okay. I will show you few questions here. Look at this data, see, if you observe in complete periodic table, if you observe, the chlorine is having highest electron gain enthalpy with minus 349 kilojoule per mole. What minus 349 kilojoule per mole. So the element with the highest electron gain enthalpy is which one? Chlorine. Okay. So from fluorine, chlorine, bromine, if we go down the group, iodine, go down the group, what happens? Electron gain enthalpy decreases. Okay. So decreases, but exceptionally chlorine is having higher because of presence of vacant d orbital in chlorine can accommodate the incoming electron which is absent in the fluorine atom. That's why these third period elements are having greater electron gain enthalpy than these second period elements. Generally what we know, smaller size, more electron gain enthalpy we know, but due to presence of vacant d orbital in third period elements like phosphorus, sulfur, chlorine having more electron gain enthalpy than respect to second period elements. Just check fluorine and chlorine. We know fluorine is more electronegative element, small size, but having lower energy than chlorine because chlorine is having vacant orbital to accommodate that incoming electron. Therefore, chlorine first, electron gain enthalpy of chlorine, next fluorine, next bromine, and least is iodine. This is the order. Okay. This is the order. Next. Similarly, you can compare for 15th group elements. Similarly, you can look into the 15th group elements and 14th group elements. So this will be the values. There are many questions asked on this particular table itself. I will show you all those. Look at these questions. Now just now I told you what is the electron gain enthalpy values for halogens are given. Chlorine greater than fluorine greater than bromine and least is iodine. So fourth option perfect. And electron gain enthalpy values for oxygen family. When it comes to oxygen family what I told you, third period element is more than second period element. So sulfur first, next oxygen should become now. So when it comes to oxygen family, oxygen is least and maximum is for sulfur, that is fixed. After sulfur we have selenium, tellurium, and least is for oxygen. Here we have fourth option here also. Okay, next. Electronegativity. So what is this electronegativity means? For example, there is a bond between atom A and atom B. Okay, this is a bond. Now I can define, look at here, electronegativity. The tendency to drag the bonded pair electrons towards itself is considered as its electronegativity. The tendency to drag the covalently bonded electrons towards itself is called as electronegativity of that particular element. See, electronegativity is a measure of tendency of an element to attract the bonded pair electrons in a covalently bonded molecule. Okay, so now this electronegativity depends upon atomic size. Atomic size means smaller size, more nuclear charge, more is the electronegativity. Okay, it means smaller size elements have more electronegativity when we compare with the larger size. So small size more electronegative, large size electropositive. You can remember this. Okay, from going from top to bottom, what happens to electronegativity? Electronegativity decreases because their size increases. Okay, you can remember electronegativity directly proportional to the nuclear charge. What I am saying, electronegativity directly proportional to nuclear charge and inversely proportional to size. So more nuclear charge, more positive charge, more tendency to drag the bonded electrons, that is nothing but electronegativity. Okay, nuclear size over electronegativity is also nuclear charge also over hybridization. So s orbital has more electronegative nature than p, then d, and then f. So it means if I take hybridization like sp hybridization, sp2 hybridization, sp3 hybridization, if I take sp hybridization is more electronegative than sp2 then sp3, like this. Okay, hope this is also clear. Guys, if things are clear, just click on the like button and also share with your friends. You can feel free to express your concerns in the chat box. If I am moving too fast, or if you are wanted to know some other parts of chemistry other than this topic, or whatever the requirements you have, just mention in the chat box. We will definitely take it as a consideration. Okay, next, look at this. Arrange the given elements based on their electronegativities. So tell me, in the periodic table, first most electronegative is fluorine and second most electronegative is oxygen. So by this, fluorine, oxygen, fluorine, nitrogen is there, and third most electronegative is nitrogen and chlorine. Okay, and after this, as per the data given here in the like we know carbon silicon belongs to same group now. The top element in the period, top element in a group will be having more electronegative all the time. So it means carbon will be more electronegative than silicon, that's it. Okay, so we have order 2 as our option. Okay, these are the electronegativity values. Try to remember this. Try to remember this electronegativity values because there are some questions to match. First electronegative element is what I told you, fluorine with 4.0. Next one is what, oxygen 3.5. Next nitrogen here and chlorine here 3.0. Next carbon, sulfur 2.5, 2.5. Next phosphorus with 2.1, whereas bromine with 2.8, iodine with 2.5. Carbon, sulfur and iodine almost having similar values as 2.5, remember that. Okay, so when it comes to hydrogen it is 2.1. Between carbon and hydrogen, carbon is more electronegative, that is 2.5 and this is 2.4, 2.1. Okay, so if you see these metals are having lower electronegativity and non-metals are having higher electronegativity. Okay, so S block elements are metals, P block elements are non-metals. So metals have electropositivity nature, non-metals have electronegativity nature, you can remember, right? So bond between an electronegative atom and electropositive atom will be ionic. What is that? Ionic. Okay, so if see, if we have element A combining with oxygen to form oxides, so if that element A is more electropositive and oxygen is more electronegative, we know. If the difference in their electronegativity value is greater than 2.3, then we can say it as a basic oxide. Difference is equals to 2.3, amphoteric. If it is less than 2.63, it is acidic oxide. You can remember this. Okay, right. See, generally alkali metals, alkaline earth metals will form basic oxides. Non-metals like P block elements here this side are forming acidic oxide. So intermediate we have now P block starting like 13th group, 14th group, they forms amphoteric. Okay, or in higher oxidation state it is acidic. These are the list. See when they are saying about acidic nature, two things you need to discuss. We need to know about acidic nature of oxides. So one is their electronegativity and other one is oxidation state. So if a more electronegative atom forms acidic oxide, and like less electronegative atom forms basic oxide. Okay, you can remember in this generalized way. And when it comes to oxidation state, higher oxidation state means no more nuclear charge now, so it forms acidic oxides. Lower oxidation states forms basic oxides. Okay, basic oxides. Okay, so these are some examples. Okay, so based on, you can answer this question, acidic properties increases in the with increasing oxidation state. See, greater the oxidation state of an element, greater is its greater the oxidation state of an element in its acid, greater is its acidic nature. See, HClO4 perchloric acid is more acidic than this HClO, the chlorate ion. Okay, chloric acid. Okay, nitric acid is more acidic than nitrous acid here because it is +5 oxidation state, here +3 oxidation state. Sulfuric acid, see +6, here it is +4. So greater the oxidation state, greater is the acidic nature. You can remember here. See here SO3, sulfur with +6. Nitrogen here it is with +3. So tell me which is more greater oxidation state, sulfur now, so that's why it is having greater acidic nature or greater acidic oxide here. Okay, this is the generalized thing you can remember. See, This arrow mark indicates the variation. So top, like from down to top, electron gain enthalpy increases. Okay, electron gain enthalpy increases, ionization also increases, both are things are increasing. Or you can understand in this way if you are confused. Down the group what happens, ionization energy decreases and electron gain enthalpy also decreases. Okay, and one more, from left to right what happens, ionization energy increases and electron gain enthalpy increases. Okay, and electronegativity also increases. You can just imagine there is a periodic table and try to summarize all the important properties in this way, so that you will get complete clarity on the properties. Okay, right. Metallic character from left to right decreases, non-metallic character increases. Okay, like this. Atomic radius left to right decreases, top to bottom increases. In this way you can make a list. Now you can go through the questions. Right. It is time for questions. Now I will show you few questions only. I will show you. Other things take it as a work. You can do this. Okay, because whatever you have here listen till now, based on that you can able to solve all these questions. Okay, even the session if I ended up here within few minutes, you need to solve those questions. Okay, because in the upcoming session I am going to solve the same question. See here, first one, identify the pair of elements in which number of electrons in n-1 shell is same. n-1 shell, it means what? See, for this iron it is d block now. So iron atomic number is 26. So what is the electronic configuration we have? So writing argon 18 over, the next 3s2, like we are writing 3d6 4s2, that's it now, 3d6 4s2. So this is the nth level electrons, and 4 and 3, this 3 is nothing but n-1th level electrons only now. So how many n-1 level electrons are there in iron here? Here we have 6. Similarly, when it comes to manganese atomic number is 25. So it will be having 3d5 4s2 configuration. Okay, so how many n-1 level electrons are there? Only 5. So it means not our first option. Okay, similarly go to this option. So zinc, it has 3d10 electrons. Okay, this is 3d6 only. This is also not the correct one. Next go to the option D here. So option D, manganese 3d6, 3d5 and chromium also 3d5, 4s1. So definitely n-1 electrons are same in this option D. So that will be a perfect answer. Okay, hope this is clear. Right, let's move forward. Look at this question. Now similar, whatever the way I have told you, just write their electronic configuration, try to find total number of electrons present in electrons present in magnesium in s orbital, total number of s electrons in Mg and p electrons in chlorine, like that you calculate, and that one which is having equal to the number of d electrons in iron. Number of d electrons are how many in iron? 6. Okay, so those options which are having 6 electrons in respective orbitals which are mentioned as spp, you calculate. If they are same, you choose that as your answer. So just try this question, and even you can try this question also. If you are unable to solve, we will discuss in the next session, that is in upcoming tomorrow's session. You can write this electronic configuration, find the answer, and here also see atomic weight, properties of elements are the periodic properties of their atomic weights. Who is the person taken here? It is Mendeleev. So option C. All these questions are PYQs only. I hope you are following the session effectively. See 1, 2, 3 I told you how to name this kind of elements, like having atomic number greater than 3. Try this and tell me, like unbitrilium, see unbitrilium. So UBT, option C. Next, nitrogen has more ionization energy, ionization enthalpy and electronegativity than beryllium. Yes, we have written now. What is the first ionization energy order for second period elements? So beryllium is somewhere here, and next carbon, next oxygen, and next nitrogen, and next fluorine, and next neon we have written. See, nitrogen is having greater ionization energy than this beryllium. Statement 1 is perfectly correct. Statement 2, chromic oxide and this boric oxide, like orthoboric acid oxide, here boric oxide only, boric anhydride we can say, both of them are acidic oxides only. Okay, so statement 1 is correct, statement 2 is also correct. Next, which are the following set of elements are not correctly arranged with the property as shown in the bracket? See, what happens to the electron gain enthalpy? I told you, oxygen family if I take, so between oxygen and sulfur always second period elements are lesser than third period. I told you sulfur, the next selenium I told you, the next polonium, least is like next tellurium, next polonium, and least is oxygen. So this is correct. Okay, next go through this one. Fluorine is more electronegative than oxygen, then next chlorine. Yes, this is also correct. Okay, they are saying not correct, not correctly matched. First two are correctly matched, and next metallic character. So what happens down the group? Metallic character increases. Lithium, sodium. So sodium is having maximum than the lithium, that is perfect. And from left to right what happens? Metallic character decreases. So that's why sodium, then next lithium, and then least is for aluminum. This is also correct. Next, metallic radius, that is asked. So here it is metallic character. What happens to the metallic character? Metallic radius also correct, and metallic nature, down the group metallic nature increases now. So potassium should have more metallic nature than this sodium, but it is given in the reverse. So this is not correct. We need to choose our D as our answer for the question. Next, ionization energy. Tell me ionization energy, which one is the correct order here mentioned? Nitrogen greater than oxygen greater than carbon, next greater than beryllium, boron. So A3. Metallic character, metals you check, where do we have metals? Yeah, sodium, magnesium, silicon, phosphorus. This is B1. Next, electron gain enthalpy is more for chlorine, fluorine, bromine, iodine, C4. Electronegativity more for chlorine, so D2. So choose the option which is having like this: A3, B1, next C4, yes, option B is our answer. Next, already we have solved this question. See, chlorine is highest electronegative element I told you, so B4, right now B4, and then next B4, if you look at the option, we have only first option, so this will be perfect answer for the question. Okay, and next A2 they are saying, just verify A2, yes, 328, minus 328. Next, between sulfur and oxygen, sulfur. So here, and oxygen is least C1, that's it. Correct order of decomposition temperature of magnesium carbonate, like carbonates are given here for second group elements. See, carbonate ion is larger size now. If this is larger size, the cation should also be larger size, then that will be more stable. Large size cations stabilizes large size anions. Okay, so large size cation is barium plus 2 here. So barium carbonate is stable, that is stability I am saying first. Stability of barium carbonate, that is Y is more stable, and the next calcium carbonate is next, followed by magnesium is least stable, that is X. Okay, so if a more stable compound is there, for its decomposition more energy is required. Here in terms of temperature they are saying more temperature is required to decompose that. So I can say stability order and decomposition temperature order same. So Y, Z, X, so first option will be perfect. Hope this is clear. If this is clear, just click on the like button, right? Let's move forward. Given oxides, we need to give the acidic strength order, which is more acidic here. I told you from S block to P block, if we move, their electronegativity increases. If electronegativity increases, their acidic nature also increases, acidic nature also increases. So it means sulfur, phosphorus, silicon, aluminum. Okay, this is the way. So we have this kind of oxide here in the order C. That will be our perfect answer. Next. So can you solve this question? Metallic nature, easy. Just now we discussed alkali metals definitely having more metallic nature than alkaline earth metals. Like that, you can choose the correct option and tell me in the comment box. Okay. So these are the questions I just wanted to discuss. I have almost covered some 20 questions in this session along with the theory whatever required for your preparation. And now this is your time to prepare once again. Go back to the notes or whatever you have written or whatever the notes you have, or take the slides as a reference. You can go through each slide, make notes out of it, and just go through the short notes which you are going to prepare from this lecture or from the notes whatever you have. Okay, and if you want this lecture notes or questions or anything more, you just join our Telegram group. That link is given in the description box, or you can contact the mobile number given in the description box for getting more detailed information. Okay, yeah, thank you for watching. If you are new to this channel, click on the subscribe button and you can share with your friends. Thank you.